Hey guys, it's me Sanjay Vasu here. Today I'm actually going to be doing Science Stage 9 Paper 2 2022 for a progression test. Let's start. Question 1. Look at the diagram. It shows the human renal or excretory system. A. Look at the table about what happens in different parts of the excretory or the renal system. Complete the table. The first row has been done for you. All the blue pen markings are what I have written and all the others are what's there in the question. I've already finished this and now I'm just showing you the answers. So this first row is an example. The renal artery, what happens is the blood enters the excretory system through this renal artery over here, white color artery. Now the kidney filters the blood because it filters the urea out of the blood so that it can purify the blood. And then urine travels through this tube to be stored. It's through this tube over here, and these tubes are called ureters. So ureter. And urine is stored here before excretion from the body. It's over here, which is bladder or the urinary bladder. That's the answer. So go to part B. Kidney failure causes a buildup of a toxic substance in the blood. Write down the name of the toxic substance. It's urea. Because when urea mixes with water, we get urine, and that's what we excrete. Part C. Artificial kidneys prevent the buildup of toxic substances like urea in the blood. Artificial kidneys use a process called dialysis. Look at the diagram of an artificial kidney. So over here we have a tube with blood that swirls like this. So the blood goes in and a dialyzing solution comes in through this small gap here. The blood, has some toxic substances like urea, and as it travels, this tube is made of a partially permeable membrane, so the urea is able to pass through and get inside to the dialyzing solution, but the blood stays inside the tube without going outside. And then the dialyzing solution and the toxic substance goes out, which is urea, the toxic substance, and then the purified blood goes out. Use the model to describe how dialysis works. So as I just explained, blood is passed through the partially permeable membrane, which means passed through this tube here, so that only the waste product is removed. And the waste product here is just urea. So the urea diffuses through the partially permeable membrane over here, and it is removed from the blood by the dialyzing solution. That's the answer. Let's go to question 2. Look at the diagram. A. Complete the sentences to describe what's happening to the sound from A to B. Choose from the list. The loudness of a sound does what, and frequency of the sound does what? The loudness stays the same because loudness is seen by the height of the wave. This height of the wave remains the same for all 5 waves from A to B. And the frequency of the sound increases because, as you can see, A has only 3 parts of the wave. But in B, there's a lot more. It just goes a lot of waves are appearing in one sound trace. Because there's a lot more waves over here, the frequency increases as there's more. That's the answer. Let's go to part B. This question is about combining sound waveforms. The diagram shows 2 waveforms, wave 1 and wave 2, that combine together. It also shows the new waveform made, which is wave 1 plus wave 2 over here. 1. Write down the word that describes how wave 1 and wave 2 combine together. If you see, wave 1 and wave 2 are actually identical waves. And if we add them up, we get a huge wave, which is twice the height or twice the amplitude of the first 2. Or in other words, it's the sum of the amplitudes of the first 2. The frequency does not change. The word that describes this is reinforcement or reinforcing. Now for part 2, 2 more waveforms, wave 3 and wave 4, combine together. Wave 3 is over here and wave 4 is over here. Everything is the same except for one thing. This wave has its peak over here and its trough over here. I'll just mark that. The peak, which is the topmost point, and the trough, I'll just mark it there, which is the bottommost point of a wave. So these are another 2 peaks, these are another 3 troughs. But now for wave 4, the peak is over here, right where the tau is in wave 3. So the peaks and taus align like this, one peak and one tau. Same thing for the other way around. There's a tau over there, and the peak aligns with the tau. So imagine the peak to be a positive and the tau to be a negative. A positive plus a negative is always equal to 0, right? If it's the same value. In this case, wave 3 and wave 4 have equal amplitude, or in other words, the height is the same. So these two will cancel out and form the straight line for all of these peaks and troughs over there. This straight line means that no sound is being heard. This is the positive sound, and this is the inverse of that sound, or in other words, a negative sound. These two waves cancel out. That's why it's canceling. That's the word. By the way, why is it not canceling here in the first part? Why is it reinforcing? Because if you look, the peaks are both here. The peaks align up with each other, and for troughs, they also align up with each other. If this happens, then it reinforces. If, as given in the second part, the peak aligns with the trough, that means it cancels. Let's go to question 3. Look at the diagrams. They show the electronic structures of a sodium atom and a sodium ion. This sodium ion is an Na plus ion, which means it has one extra proton compared to electrons. In a normal sodium atom, there are 11 protons, 11 electrons. Over here, there's 11 protons and 10 electrons. It lost an electron so that it can get an octet structure. Or in other words, all the shells, like this, the inner shell and the second shell, are full. This electron, which is extra compared to these in sodium, is a valence electron. Which means if we remove this one, we get an octet structure. In magnesium, there will be 2 valence electrons. There will be another one there, because magnesium is the next atom after sodium. A. Describe how a sodium ion is made from a sodium atom. As I just said, the sodium atom loses an electron, in this case the valence electron over here, to become the sodium plus or Na plus ion. If you didn't know, these positive ions can also be counted as cations, and negative ions can be counted as anions. Now let's go to part B. Look at the diagram. It shows the structure of sodium chloride. 1. Write down the name of the type of bonding in sodium chloride. As you can see here, we have an Na plus cation and a Cl minus anion in this molecule here, in the structure of sodium chloride. And because they both are ions, it is ionic bonding. Part 2. The bonding between sodium ions and chloride ions is strong. Explain why. Well, sodium gives one electron to chlorine. That's why it is a Cl minus. It has one extra electron than proton. In other words, chlorine has 17 protons and 18 electrons. 18 electrons. Why is it specifically 18? And why not you add 2 electrons to chlorine and subtract 2 electrons from Na, which is sodium? Well, I'm just going to draw a small atomic structure of chlorine. They'll be having 1, 2, 3 shells, like that. They'll have 2 electrons here. 2, 4, 6, 8 in the second shell, and 2, 4, 6, 7 in the third shell. This will have 2 plus 8 plus 7, which is 17 electrons. Now Cl minus, you get an extra electron, which means you will get 2 in the inner shell and then 8 in the next, 8 in the outermost shell. And if you add 1 more electron, it'll go in the outermost shell, which is the next shell after this one. So the Cl minus has an octet structure, which means you cannot add any more electrons in the outermost shell. That's why we add specifically only 1 electron to become Cl minus. So I'll just say that this is a Cl minus ion. By the way, this has 17 protons. And because of what I just said, ionically bonded compounds have octet structures, and because of that, they are strong. Part 3, sodium chloride has a giant structure. Circle the melting point of sodium chloride. Giant structures are very strong, and because of the ionic bonding which is present in it. And because of that, it'll have a really high melting point. So I've circled 801 degrees. Let's go to question 4. This question is about tectonic plates. A. Tectonic plates float on molten magma in the mantle. 1. Write down the name of the layer of the earth made of tectonic plates. It is the lithosphere, and also you can write crust. Both are correct. Lithosphere is the layer of the crust which is made of tectonic plates. 2. Explain why tectonic plates float on the mantle. Well, it's quite simple. Just think about the word float. How does something float on another? One of them has to be less dense than the other, right? In this case, tectonic plates are less dense than magma, and that magma is present in the mantle. Even if you write less dense than the mantle instead of magma, it's still correct. Go to part B. UV models what happens at the boundary between two tectonic plates. Look at the diagram of UV's model. Each large piece of biscuit, which are these two, models a tectonic plate. The large pieces of biscuit float on the cooking oil, which is over here inside the dish. The cooking oil models the magma in the mantle. As we saw in part A2, tectonic plates are less dense than magma, that's why they float, so they have represented it like this. Part 1. Which part of the earth does the lighted candle in the model represent? Well, this candle produces heat energy or thermal energy, right? And which part of the earth produces thermal energy from the center? It's the core. And that's why I've written core here, or you can write just Earth's core, like that. Part 2. Predict what will happen to the pieces of biscuit. Explain your answer. So the prediction is the pieces will move apart. Why? If you see the candle, it's at the middle of these two pieces of biscuit. This thermal energy will rise up there. And because of that, this energy will rise up, and this thermal energy will be diverted here in this direction, and then the cooler air will be diverted downwards, or the cooler energy, which means ones which have not been affected by the candle's thermal energy yet. And then when it comes over here, it'll be affected by the heat. It'll heat up and it'll rise up, because hotter things rise up and cooler things sink. Or in other words, hotter air rises up and cooler air sinks. And the cycle will just continue like that. This is called the convection current, and that's pretty much the full explanation. Because of that, this thermal energy will move here, the air will move that way, or in this case, the liquid will move that way. So first of all, convection current doesn't have to be only air. It can be also liquids, right? So it can be liquids or gases. Air is just a non-scientific term. So because of the thermal energy which is being supplied to this point over here, this liquid will rise up and it'll push the biscuit along with itself to go outwards. And the same for this side, thermal energy will rise up, it'll go over here, and it'll push both the biscuits away from each other. So the explanation is simply the convection current due to the heat rising up from the candle. You do not have to write it like this. You can also explain convection current a bit. It's not that you have to write exactly what I have given over here. There's quite a few ways to write it. That's the answer. Part 3. The map shows the positions of earthquakes on the Earth's surface. All the dots which are given here, here, and in a lot of places in the map are earthquakes. Explain how the positions of earthquakes are used as evidence for tectonic plates. So first of all, earthquakes are caused by tectonic plate movement. So because tectonic plates move, like we saw in the previous parts of this question, the tectonic plates split apart or actually also come together sometimes. Because of that, earthquakes happen. And they happen mostly at tectonic plate boundaries because the tectonic plates can split in these boundaries only. They can move apart, or they can come together, or one goes this way, other goes the same way. This all can only happen at the boundary of a tectonic plate, or at least it can mostly happen at that place. That's why earthquakes are evidence. Now you can go to part 4, write down 2 other features that are used as evidence for tectonic plates. Well, fossil record can be used because the fossil record on, for example, South America's east coast and Africa's west coast are very similar, stating that actually these two continents might have been joined together at one point of time. And how were they joined together? Because the tectonic plates moved after a certain period of time to form what it is right now. In other words, just continental drift. Alignment of magnetic materials in the Earth's crust can also be said because the magnetic field of the Earth always flips every 500,000 years or so. This is quite large of a time, but still it takes that time. And because of that, we can say the alignment is also useful for that. See, there have been 5 times in Earth's history when most of the organisms living became extinct. This is called mass extinction. One example is when many million years ago an asteroid collided with the Earth and all the dinosaurs were wiped out in the period. And it's not just the dinosaurs, a lot more species were wiped out. It was known that 75% or greater of the total were wiped out. So that's one example of mass extinction. Scientists think that enormous volcanic eruptions cause these mass extinctions. Explain why. Although, yes, the scenario which I gave about the wiping out of dinosaurs was not caused by a volcanic eruption, others could have been caused by volcanic eruptions because they release toxic gases like carbon dioxide or sulfur dioxide into the air. Not just these two, it can release, for example, sulfur monoxide or even other gases. But the important part is that they are all toxic gases. So because of this toxic gas release, most of the organisms breathe it in and it caused huge damage for their health. And also, it settled in the air like clouds, but then dark clouds, which made sure that there was no sunlight coming into the Earth's surface. This meant that most of the plants could not photosynthesize and therefore they just died. And because of that, most animals also died. They could not find good food for a while because, for example, herbivores only eat plants. If the plants died out, herbivores will also die out. And carnivores eat these herbivores and they will also die out. And yes, that's how extinction happened. And now with that, we can go to question 5. Here find some information about the effect of smoking on fetal development. Look at the graph. It shows birth mass of 16 babies born to non-smokers and 16 babies born to smokers. The graph also shows the gestation period, which is the period of the fertilization of an egg and the birth of a baby. A1. Look at the birth masses for a gestation period of 36 weeks, which is this line here. One of the birth masses is anomalous. Circle the anomalous birth mass on the graph. As you can see, I've circled it here because smokers are meant with crosses here, and smokers logically will have babies born with lower birth mass. But then over here it's given that this one is born with a higher birth mass than even the non-smoker over here. And it's actually even higher than the non-smokers ones for 37 weeks. So that's very much anomalous, right? And if this wasn't enough, even 38 weeks is outstripped by this one period. And also if we look at all the other points over here, all the other smokers' points, they are quite low compared to this one, which is suddenly very high. So this is obviously anomalous. 2. Suggest one possible conclusion from the data. Well, as you can see, excluding the anomalous result, smoking causes decreased birth mass for the baby. B. Describe one way the evidence collected could be made more reliable. Well, we can see that's tested 16 plus 16, which is 32 babies. Why not they test a bit more, like 50 or 100 or something like that. So they can test the birth mass of a higher sample of babies or a higher number of babies. That's the answer. Let's go to question 6. Look at information about the group 1 elements. A. Lithium is above sodium in the periodic table. Predict the melting point of lithium. So as you go down the periodic table, group 1, the melting point decreases. So if you go up to the top, which is lithium, that's the top of group 1, it should be increased, right? So we have to add a value which is significantly greater than 98, but not too high. 140 is a happy medium for that. We can also write any value between 105 to 200. Let's go to part B. Cesium is below rubidium in the periodic table, which means it's the next element in group 1. Predict the boiling point of cesium. As you can see, just like melting point, the boiling point also decreases as you go down the group. So we can write a number which is significantly less than 688, but not too less. You cannot write 400 because it does not obey this pattern given here. Over here, it decreases by 124. Over here, it decreases by 71. And we should not make it decrease by too much. So it can be about 600 or like 620, stuff like that. Not greater than 650. And it should be not less than 550. Let's keep x as the value for this, so you can write any value in between this. See, which of the 3 elements in the table is most reactive? Out of these 3 elements, rubidium is the most reactive because it has a lower melting point and boiling point. That's the answer. Let's go to question 7. Aiko is in a hot room. She starts to produce perspiration, or in other words, sweat on her skin. It is a watery liquid, as we all know. It helps Aiko to control her body temperature. Complete the sentences to explain how. Choose from the list. Well, all these 3 sentences, if you've seen already, actually just describes cooling by evaporation. And I'll show you how. The water in the perspiration begins to evaporate. During this process, the water absorbs thermal energy from the skin. The temperature of the skin decreases. Why? Because the water absorbs the thermal energy and evaporates, which means it's no longer on the skin, and that's why the temperature decreases. That's the answer. Let's go to question 8. This question is about inheritance in humans. Reproduction is important for the survival of the species, which is humans. A fertilized human egg cell contains 46 chromosomes. How many are there in a sperm cell? Explain your answer. A fertilized human egg cell has 46. Fertilized human egg cell consists of 1 sperm cell and 1 egg cell. Unfertilized, actually. And if they combine together, we get this fertilized human egg cell. So that means because sperm and egg cells have the same number of chromosomes, because of that we can say 46 divided by 2, which is 23. Half the number of chromosomes in the fertilized zygote, which is the human egg cell which is fertilized. Half the number of chromosomes there are present in both sperm and egg cells. Let's go to part B. Human sperm production is damaged by temperatures 2 degrees Celsius above normal body temperature. This could affect the survival of the human species. Suggests how an increase in the temperature of the environment affects the ability of humans to reproduce. As given in the question, high temperatures reduce sperm cell production. Not even that high, just 2 degrees above normal body temperature. Therefore, there will be no sperm cells left, or at least minimal amount, and that means reproduction will not be possible, or it will be very less. Only if a sperm and egg cell fertilize, it's possible to form a zygote, which is the first cell of a new life. But if there's no sperm cell, it's not possible, and that's why reproduction will also not be possible. Let's go to part C. Write down the word that describes the total number of individuals of the same species. That's just the population, because it shows the total number of whatever species we have, but the total number of people, for example. Let's say the total number of people in India is 1.4 billion, like that. Instead of saying that, we can say population. In a similar way, we can say for different species as well. That's the answer. Let's go to question 9. Question 9. Chen investigates the rate of reaction between calcium carbonate and dilute hydrochloric acid. Look at the word equation for the reaction. Calcium carbonate plus hydrochloric acid gives calcium chloride plus carbon dioxide plus water. Look at the equipment Chen uses. He has a weighing balance, he has the dilute hydrochloric acid and calcium carbonate powder, he has a conical flask, and he has a glass wool plug. Glass wool means a kind of substance which is used as a stopper for the flask here. A. Predict what happens to the mass reading on the balance during the reaction. The mass actually decreases because we can see that carbon dioxide product over here escapes through the glass wool plug, and that's why it takes the carbon and oxygen atoms, or at least some of the carbon and oxygen atoms, out with it, and because that carbon and oxygen atoms have mass, this mass decreases as it escapes. B. Chen finds that the rate of reaction is greater when he uses powdered calcium carbonate rather than lumps. Explain why using the particle model. Well, we can use surface area to explain this. As the calcium carbonate is powdered, there'll be higher number of particles at the surface which are ready to react. So I'll just say using 4 1x1 cubes. If we put it like this, the surface area will be lesser. But if we put it like this, 4 separate cubes, if we do it like that, there'll be more surface particles which are able to react. Over here, it's not enough. It'll take longer time because it has to get the outside first. Once the outside is reacted, then it has to slowly go to the inside of the cube. For these ones, it can react more at the same time. And that's why I've written here, we need to write something like that. Part C. Describe one safety precaution Chan must take during his investigation. Actually, it's just wearing safety gloves and glasses. You might ask, well, that's quite obvious, right? It's not given in his apparatus over here. So that's why it's just written. And why does he take it? You know, he's using hydrochloric acid, and even though it's dilute, it can still cause damage to the eyes or skin. Because of that, we can use safety gloves and glasses to prevent the damage of the eyes or skin if the acid spills or if somehow it accidentally lands on your hand. That's the answer. Let's go to question 10. Angelique wants to measure the current and voltage in a circuit. A. Look at the circuit diagram. 1. Angelique measures the current using an ammeter. Draw the position of the ammeter on the circuit diagram and use the correct symbol for the ammeter. I've done it over here. You can draw it anywhere within this circuit wire over here. It has to be using this symbol with a circle and an A inside like given there. That's the answer. Let's go to part 2. Angelique measured the voltage across the lamp using a voltmeter. Draw the position of the voltmeter on the circuit diagram. Use the correct symbol once again. Yes, in this case, ammeter was connected in series with the cell because we are measuring the current in the full circuit, which means current to the cell. But here, voltmeter must be connected in parallel, like I've done here, and parallel to the lamp because we are measuring the voltage across the lamp. So connected in parallel, 2 sides of the lamp we connected, and put a symbol with a circle and a V inside it. That's voltmeter symbol. That's the answer. B. Angelique builds another circuit. Just now it was a series circuit, but here it is a parallel circuit. Describe what happens to the current in the circuit at point A. We can see that the current goes over here, like that. And then at this point, the current has 2 ways to go. So it can go here and it can go here. And it'll join back over there and come back to the cell. So at this point A, the current splits into 2 directions like that. So we can write the current splits. That's the answer. Let's go to question 11. Hassan investigates if objects float or sink when placed in cooking oil. So he has a range of objects over here, and using those, he's checking if they float or sink. Look at the table of densities. He has all the 8 materials over here, and he has the cooking oil density there. A. Hassan uses the diagram and the data in the table to make a hypothesis about which objects float and which objects sink in cooking oil. He wants to link the density of an object to if it floats or sinks in cooking oil. Suggest the hypothesis Hassan makes. We know that the density of cooking oil is 0.9 grams per centimeters cubed. And if the density is less than 0.9 centimeters cubed, then it'll float. That's the rule of density. And the same way, if it's greater than 0.9, it'll sink because it has a higher density. And you can write any one of these points. It doesn't have to be both the points together. The answer. Part B. Hassan investigates if objects made of plastics of different densities will float in water. Describe his investigation. So first, he will measure the density of a range of different plastic objects or blocks. We can take a few different kinds of plastics, make a small cube out of them, and measure the density, or at least find out the density if not measure it. And then you can put it in the water and record if they float or sink. This is the proof. If the density is less than water's density, which is 1, that means it'll float. And if it's greater than 1, that means it'll sink. That's the answer. With that, I come to the end of my video. Please like this video, subscribe to our channel, share this video with your friends and family, and comment on how you think this video was. With that, it's me, Sanjay Vasu, signing out. Thank you. Bye.